Hello, it's Mr. Best. Welcome to Chapter 7, homework questions 83 through 89. Question 83. Use Tramika's method from problem 7-78 to find the area of an equilateral triangle with side length of 12 units. Show all of your work. So let's go through. We'll set up our equilateral triangle. They all have 12 units. How are we going to find the area using Tramika's method from 7-78? So you're going to have to go back to that problem to do it the same way. So the way it's set up is we start by drawing the height of the triangle. I probably should have drawn my triangle a little bit better. Remember, this is an equilateral triangle, so all the angles are the same of 60 degrees. And if my triangle is a little bit more accurate, that does split the 60-degree angle up on top. So it does bisect it, so it makes it 30 degrees. And once again, going back to Tramika's method, you will see that on there. So we know that that's 30 degrees. We also then know that since it's going to bisect the equilateral triangle, so if the total is 12 units, then each of these side lengths would be 6 units. Once again, my triangle's not really drawn to scale here. So we now know that these lengths are also congruent. And this will be a right angle. And so we're going to try to find the height of that triangle. And we can do that by using our tangent ratio. So we're going to use tangent of 30 degrees. So we'll use this angle right here. Is opposite, which is 6, over adjacent. And that will be the height, or this length right here. And so we need that to find the area. So we'll multiply both sides by h. That's h times tangent of 30 degrees is equal to 6. And then we can divide both sides by tangent of 30 degrees. So h will approximately be 10.39. Since we have to use that to find the area, I want to get at least a little bit more accurate. So now we can find the area because we have 1/2 base times height. So that would be 1/2. The base is this full distance of 12 times the height we just found to be approximately 10.39. So multiply those three together to get the area. So that'll give us an area of approximately 62.3 units squared. The other thing that we could have done, we went and used my tangent ratio, but because this is a 30, 60, 90 triangle right here, you could use your shortcuts for a 30, 60, 90, and that would actually put your height at 6, because it's square root of 3 times your short leg, so it'd be square root of 3 times 6, so 6 square roots of 3. So if you remember those shortcuts as well, you could use those.
Question 84. The guidelines set forth by the National Kitchen and Bath Association recommends that the perimeter of the triangle connecting the refrigerator, stove, and sink of a kitchen be 26 feet or less. So here's the refrigerator, you have the sink, and the stove. Lachey is planning to renovate her kitchen and has chosen the design below. Does her design conform to the National Kitchen and Bath Association's guideline? Show how you got your answer. So take a look at the diagram. What is it that you have, and what is it that you need to find? So remember, we're looking at the perimeter of the triangle that is connected. You can see it on the dotted lines of a kitchen be 26 feet or less. So we know that we're looking for the perimeter of this triangle. We need it to be less than or equal to 26 feet. So right now, what do we know? Well, we know this side length right here, as marked, is 7.2. We have the leg of this right triangle is 3, and this one is 7. So let's go ahead and find the hypotenuse, because that'll give us a second part of the triangle that we need. So we will do 3 squared plus 7 squared is equal to, we'll just call it x. So that's x squared. So we have 9 plus 49. And that will be 58. And then you can take the square root of both sides. And once again, since it's a distance, we've talked about this, that there are technically 2 answers because it's the absolute value of x. But it is a distance, so we're only going to deal with the positive. So we'll take the square root of 58 and get approximately, 7.6. And so now we have this length is 7.6. And so now we have to figure out the third side of this triangle. Now, it's not a right triangle. We have 101 degrees there, so we can't use that. I'm not going to be able to use our trig ratios. So what else can we use? Well, we have the law of sines and we have the law of cosines to help us solve triangles that are not right. And if you look at this one, we have a side length, an angle, and a side length. So law of sines won't work because we don't have enough information. We don't have the side across from the angle. So it looks like we are going to use law of cosines, and I'll just call this this side A. And so to find A, law of cosines is A squared is equal to your two other side lengths squared. So that's 7.2 squared plus 7.6 squared minus 2 times those same two side lengths. I don't know why I keep writing 7.5. 7.2, 7.6, and then cosine of the angle opposite that you're looking for, which is 101 degrees. So plug that whole thing into the calculator, and then we can take the square root to see what that distance of A is. And so we get a value of approximately 130.48. I just left that number in the calculator as is so I can get my most accurate answer. Took the square root of both sides, and A is approximately 11.4 if we're rounded to the nearest tenth. So now we have all three sides. So now we just got to see if it is less than or equal to 26. That's 7.2 plus 7.6 plus 11.4. And we want that to be less than or equal to 26, and it is 26.2, which is not less than or equal to 26. So does her design conform? And the answer to that is no. And you can, see the work that was done to be able to figure out that the perimeter is not less than 26 feet. Question 85. Examine the triangles below. For each triangle, solve for x and name which tool you use to solve. Part A, we have a right triangle. 40 degrees is one angle. You could find the other angle because they have to add up to 90, so that's 50 degrees if that's helpful. But we can also just use our trig ratios. Since we have an angle, we have an opposite side, and we have the adjacent side, which is what we're solving for. So we can solve using the tangent ratio. Tangent of 40 degrees is equal to opposite, which is 9 over adjacent is x. You can multiply both sides by x, and then that doesn't solve for x, so then you have to divide both sides by tangent of 40 to get it by itself. So plug in 9 divided by tangent of 40, and we'll round to two places on these, so x is approximately 10.73. And that would be in centimeters. And it also makes sure what tool did you use. We use the tangent ratio. All right. Part B. This one we do not have a right angle. You could once again find the third angle by, on this one, taking 180 minus those two. So we're not going to be able to use Pythagorean theorem. We're not going to be able to use our trig ratio, sine, cosine, and tangent. But we could use the law of sines or the law of cosines. Since we do have two angles, we can always find the third angle. So let's go ahead and do that. We're going to find, we'll just call it capital A. So A is equal to 180 degrees minus 63 degrees minus 52 degrees. So what will angle A be? And that will give an angle of 65 degrees. So since we have all three angles and a side length and another one that we're trying to find, we can use the law of sines. So that will be the tool that we use. And we can take sine of 65 degrees over 8. And we want the angle across from x, which would be sine of 63. And that will be over x. And then we can solve law of sines, multiply both sides by 8x. So I'm just going to take this, both sides by 8x, cancels the 8, then it leaves you with x times sine of 65 degrees, cancels the x, leaves you with 8 times sine of 63 degrees. And then we want to divide by sine of 65 degrees since it's x times sine of 65. We need to undo that by division. And when you plug that into the calculator, you should get x is approximately 7.86. And this is measured in miles. All right, in part C, we have, once again, a triangle has 68 degrees as one angle. Doesn't give us enough information to find the other two. We do have two side lengths. Law of sines will not work because we don't have an angle and then a side length that we know across from that. So let's go ahead and set up our law of cosine. Since we are looking for the third side length and we have that included angle, we should be able to use law of cosines. And so that will be x squared is equal to 12 squared plus 15 squared minus 2 times 12 times 15 times cosine of the included angle, which is 68 degrees. Plug that whole thing into your calculator and then take the square root of it. And that will give you approximately 234.14. And that's approximately. And then you take the square root of both sides and we get x is approximately 15.3. If we're going to round to two places, it would be 30. And that would be measured in feet. And then law of cosines was the tool that we used. Question 86. For each figure below, determine if the two smaller triangles in each figure are congruent. If so, create a flowchart to explain why and then solve for x. If the triangles are not congruent, explain why not. Alright, so in part A, I'm trying to figure out if the triangles are congruent. Remember the 5 different ways that we can prove triangle congruency. We have side, side, side congruency. We have side, angle, side congruency. Angle, angle, side congruency. Angle, side, angle congruency. And then if it's a right triangle, we have hypotenuse, leg congruency. So those are the 5 that we know we can prove that triangles are congruent. So if you take a look at what we have on the first figure, we have this side length is congruent to that one. We have this angle is congruent to that other one. So right now we have a side and an angle. So if we have an angle, we need either angle, angle, side or angle, side, angle. But we also could potentially use a third side. And since these triangles have this side length in common, then that means that this side length is congruent to itself. And so that would give us side, angle, side, which is one of our congruency statements. So we can prove it, that they are congruent, and then we can find the value of x once we do that. So it does want us to create a flowchart. So at least for the first one, I'll create a flowchart so you can see how this is going to go, and then we'll solve for x. So what is the first thing? Well, you're given some information here. We also probably want to label these vertices so we can name things correctly. We're given that AB, line segment AB, is congruent to line segment CD, and that's given. We're also given that angle BAC is congruent to angle DCA. And we got to justify that by a reason. So those were given to us from the picture. We then were able to say that AC, try to stick to my colors here, AC, line segment AC, is congruent to line segment CA. And the reason for that is the reflexive property. Okay, so those are the 3 things that we need. We have side, angle, side, and then that will create our triangle congruency. So now we can say triangle ABC is congruent to triangle, let's see, that would be CDA. And so all three of these go to that, and we know that the triangles are congruent by side, angle, side, congruency. Go back and make it blue. Side, angle, side. And so there's the flow chart. Let's go ahead and solve. If that is true, then we know its congruent parts are also congruent. If two triangles are congruent, we know its corresponding parts are congruent, So that means this side length is equal to this one. So we should be able to set up 6x plus 6 is equal to 8x plus 2. Subtract 6x to make that 2x. Subtract 2, that'll be 4. Divide by 2. And x is equal 2. So let's make sure we did everything. So create a flowchart, did that. Did our explaining why with our justifications, and then we solved for x. So it looks like we're good to go. If we wanted to find the side lengths, we would plug those back in, and we could solve for the side lengths. So this 12x minus 2 wasn't necessary in the problem to solve for x. We were able to do that with the two other side lengths. All right, so for part B, I'll make that there. We have two triangles again. You can see that the 40 is congruent, so you can tell that by the figure. You also have two right angles, so we're dealing with right triangles. And then we have another length of 41, and then another length of 9. Now, for both of these triangles, we can find the third side because we have two sides of the right triangle. So if you do Pythagorean theorem and you do 9 squared plus 40 squared equals, x squared or whatever, you're going to find out that x is equal to 41. So we know this is 41. We can also do the same thing. You'll notice that they're the same, 40 and 41, so that means this side length just right there of that triangle is a 9. So you can find all that information out. We have all three sides, so yes, it is congruent, side, 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 congruency, but we also could just use the last one, the hypotenuse leg, because you do have the hypotenuse, which you know is 41. This one you know is 41, and then you have the 40 that was given to you in the beginning. So lots of different ways that you could potentially prove this congruency. You also have side, angle, side. So we'll pick one of those. I'm going to erase some of this so I can go back to what was actually given to us. Try it again. And start the flow chart. So what do we know? Well, we know that side length 40 is congruent. So let's measure, give these vertices some labels, A, B, C, and then we'll do D, and this point right here we'll call E. So what do we know? Well, we know that AB, line segment AB, is congruent to line segment BD. All right, and that's a leg of the hypotenuse. We also know that this part right here, 41, is the same as this one. So let's do, we'll go BC. Line segment BC is congruent to, make sure I match this up, DE. And so this one right here was given to us. They were both 40. This one here actually was figured out because of Pythagorean theorem. And the work to that really is up here, so we could tie that in there if we needed to. And then those two can create our triangle congruency because we can use hypotenuse leg. So we can say that triangle ABC is congruent to triangle, that would be BDE. And we know that by hypotenuse leg congruency. So now that we know they are congruent, we can find the value of x. We know this length right here, we said earlier, was 9. And the whole length of that hypotenuse is 41. So to solve for x, we just can take 41 minus 9, and that will give us 32. So x is equal to 32 units. And so that creates the flowchart and solving for x on part B as well. Question 87. The diagonals of a rhombus are 6 units and 8 units long. What is the area of the rhombus? Draw a diagram and show all the reasoning. So you can see the diagram is already on there. Let's go ahead and create the diagonals of the rhombus. Alright, so let's say the red one is 6 units and the blue one is going to be 8 units. And I don't want to write those on the picture because I'm afraid that we're going to think one of the shorter line segments is that. What is the area of the rhombus? Now the rhombus is a parallelogram, so we really just need the base and the height. So can we find those things with the diagonals that we have? Or if we found the area of the triangles inside, we could add them up. So a couple different ways we go about doing this. And let's just kind of get started here and see what we can do. So remember the diagonals of a rhombus bisect each other, so that means that this length here would actually be 4, and this would be 4. And then on the 6, we have 3 and 3. Also, they are perpendicular bisectors, so they do form right angles. So all of those triangles in there are right angles that have lengths of 3 and 4. So that means they are congruent, all 4 of them, because you have a side, an angle, and a side. So if we can find the area of 1, then we can multiply it by 4 and find the total area. So let's go ahead and do that. So if we look at this triangle here, we have a side length of 3, which is a leg, another side length of 4, which is a leg. So if you remember your Pythagorean triples, that means this length right here would be 5. It's a 3, 4, 5 triangle. Or you can use Pythagorean theorem, it'll work either way. But the area of one of the triangles would be 1/2 times the base, which would be 3 if you're looking at it that way, times the height is 4. So the area of 1 would be 6 units squared. So then we can take that, since there's 4 different congruent triangles, and that means we'll get the area of the rhombus to be 24 units squared. And once again, multiple ways to look at this, but that was just kind of my first instinct when I started the problem. Question 88. Kendrick is frantic. He remembers that several years ago he buried his amazing electron ring in his little sister's sandbox, but he cannot remember where. A few minutes ago, he heard that someone is willing to pay $1,000 for it. He has his shovel and is ready to dig. Part A. The sandbox is rectangular, measuring 4 feet by 5 feet, as shown at the right. So you can see that in the diagram. If Kendrick only has time to search in the 2-foot square shaded region, what is the probability that he will find the ring? So, probability. Well, what's the area of the entire thing? So, if it's a 5 by 4, we have a 20-foot area. Alright, so that's the area that is potentially going to be covered, but he can only dig in a 2-foot by 2-foot region, which is 4 feet. So there's a total of only 4 feet that he can actually has time to dig for. So what is the probability of that happening? Well, he can dig 4 feet out of a total of 20, so that would be 1/5, which you can 0.2, or we can say is 20%. So he has a 20% probability of finding the ring, or once again 1 out of 5. Part B, what is the probability that he will not find the ring? So in terms of not finding the ring, 1 represents 100%, and if we subtract the 1/5, which is him finding the ring, that leaves us with 4/5. Or we can say there's an 80% probability that he will not find the ring. And then on part C, Kendrick decided instead to dig in the square region shaded at the right. Does this improve his chances for finding the ring? Why or why not? So I think I said that wrong, but he decides to dig in the square region shaded at the right. So it's still a 2 by 2, which means the area is still 4. In the picture itself, it seems like that square is a little bit bigger, but it's still a 4-foot square, so it doesn't matter, where it's at in the sandbox. It's still 4 out of 20. So even if you change the orientation of the square that he's going to dig in, it's still going to represent the same probability 1/5. So does this improve his chances? No. It is still going to be 4 feet over a total of 20 feet. So once again, that's still 1/5 or 20%. Because once again, this area did not change from this area up here, so the probability is not going to change. Question 89. What is the 50th term in this sequence? Well, how is this sequence growing? Well, in this case, you're adding -3 each time, so it's actually decreasing, but it's by a constant. You're adding -3 over and over again. So when you look at this sequence, it's going to be arithmetic. You need to know where it starts and what its growth is. So we know the growth, which represents our slope, is -3. And our first term, a sub 1, is 17. But we would like to know what a sub 0 is. That's basically your starting or your initial or your y-intercept. And so we can go back a term and get 20. And so now we have everything that we need to write the equation, and then we can find the 50th term. So in terms of the equation, t of n is equal to -3 times n and then plus 20. So if I'm looking for term, in this case, let's go down to term 4. Then if I plugged in 4, it would be -3 times 4 plus 20, which is 8. So we have the equation. Once again, it's linear. It's that arithmetic sequence. And so if I want to find the 50th term now, I can just plug this in. -3 times 50 plus 20. And that would be -150 plus 20, which would be -130. So the 50th term, we can even write it this way, is equal to -130.